Beyond the Mic with Sean Dillon.
We're joined on the star line by theoretical astrophysicist exploring a range of questions in cosmology, the study of the universe from beginning to end. Her book, The End of Everything, Astrophysically Speaking, takes us on a tour of 5 potential cosmic end-of-day scenarios. We welcome Dr. Katie Mack.
Hello. Hi. Thanks for having me.
Astro Katie, let's go beyond the mic.
Mm-hmm.
You started at Caltech for your BS, went to Princeton for your master's and PhD, was a Cambridge and Melbourne research fellow, and now teach in North Carolina. When you were growing up, did you ever think you're going to be such an academic wanderer, end up where you are today?
I really had no idea. I didn't know when I was growing up how much academics travel and move, and the idea that I'd be bouncing around the world for a decade or so was not something I anticipated. But it has been amazing to see just how international this field is, and how much people from all over the world work together and travel around and spend time in different places. And I think that's actually kind of been great to have a chance to see the world as an academic.
Now, how has North Carolina State, where you teach, embraced the stardom you've received without even being a tenured professor?
I think my university is very happy that I'm getting some attention and that the book is doing well. They're very supportive. The position that I have there is one that's officially combining research, teaching, and public engagement, and so they've always been very supportive of my public work, which is a little unusual in academia. So I've appreciated that a lot.
We're talking to Dr. Katie Mack beyond the mic from your book, The End of Everything, Astrophysically Speaking, The Big Crunch, Heat Death, The Big Rip, Vacuum Decay, and Bounce. 5 seemingly scary names for cosmic disasters. Let's take the fear out of the situation.
Okay.
What are the odds that any of these will happen in the next day or so?
Oh, basically zero. I mean, there's a lot that we don't understand about the universe. There's a lot that's unpredictable in one way or another. But based on our understanding of the cosmos, nothing big and cosmic is going to happen to us for a very, very, very long time. There's most things in the universe happen slowly, and they take billions of years to develop. So there's really nothing to worry about on short time scales. Good.
If you could put it in simple terms, how would you describe the Big Crunch?
Yeah, so the Big Crunch, and in fact, the first 3 of the scenarios I talk about in the book are all based on the question of what's going to happen with the expansion of the universe. So right now we know that the universe is expanding. We know that distant galaxies are getting farther apart from each other. And we can kind of dial back that expansion to realize that at the beginning of the universe, everything was close together and the universe was very dense and so very hot. And so we know that the universe started in this hot, dense, kind of fiery state, and we call that the Big Bang Theory. And so now we know the universe is expanding, that things are getting farther away, and that expansion was kicked off by the Big Bang. Now the question that we come to from that is, will that expansion continue forever, or will the gravity of all the stuff in the universe slow the universe down enough, slow the expansion down enough that it'll stop and everything will come crashing back together? Right? That's kind of the question. And the Big Crunch is what happens if gravity wins and the expansion slows down, stops, and reverses. And so that would be, what would happen there is that all those distant galaxies that are currently moving away from each other and moving away from us would reverse and start moving toward us, and everything, all these distant galaxies would come crashing into us, and the universe would get very hot and dense again, and that would just, sort of incinerate everything. That's what the Big Crunch would be.
Boy, nothing scary about that.
Yeah.
What about heat death?
So the heat death is, it sounds similar in the sense that, heat death sounds like a fiery kind of thing, but it's actually kind of the opposite. What happens with the heat death is that the expansion does continue forever, so it never reverses. But in fact, the expansion keeps going and speeds up. And that's due to something we call dark energy. We don't understand what dark energy is. We know that there's something that's making the universe expand faster. And so over time, that would become the dominant thing in the universe that would just make the universe expand faster and faster and faster. And so everything gets farther away from everything else, and the universe kind of empties out. It kind of just becomes this very, very cold, dark, empty place. And so, 100 billion years in the future, everything's so far away that we can't see other galaxies anymore. All those beautiful pictures you get from the space telescope of these galaxies with spiral arms, we wouldn't be able to see those anymore because the galaxies would be so far away from us that the light wouldn't be able to reach us.
Wow. And
eventually you get to this state where the universe is just basically completely empty. All the stars have died out, all the matter has decayed, and you just have this cold, dark, empty space. And it's called the heat death because the only thing that's left over in that cold, dark, empty state is like a tiny amount of trace, like waste heat from the universe decaying. So it's a very bleak future. It's a very slow process, but it's sort of the opposite of the Big Crunch in that it's the universe just totally emptying out.
It's Dr. Katie Mack. The book is The End of Everything, Astrophysically Speaking, and it's available now. 2 theories down, 3 to go. Could you please tell me about the one with my favorite name, The Big Rip?
Yeah, so the Big Rip is it's a kind of worst case scenario for dark energy. So I mentioned dark energy is something that's making the universe expand faster. It's moving galaxies away from each other. But in a Big Rip scenario, dark energy is this particularly powerful kind of dark energy that we call phantom dark energy, where it would not only move galaxies away from each other, it would actually start to rip apart matter itself, like rip apart galaxies, rip apart solar systems. So it would just get more powerful, like within structures, within objects. Right now, the way we think of dark energy is that it's just making empty space bigger. So it's just moving things away from each other. When we think about the expansion of the universe now, like this room isn't expanding, the Earth isn't expanding, the galaxy is not expanding, but things outside of the galaxy are getting farther away. But if dark energy is this special, ultra powerful dark energy, phantom dark energy, then it does start expanding actual things. And so it gets to the point where it's tearing everything apart. First galaxy clusters, then galaxies, then solar systems, then planets. And then at the end, it's tearing apart atoms and subatomic particles and just the space itself. And that's the process called the Big Rip. So we don't think that dark energy acts like that, but we can't completely rule it out based on the data yet. But we do know that if that were to happen, it would be a very long time from now.
What about vacuum decay?
Yeah, so vacuum decay is it's a very weird sort of out of left field possibility for the end of the universe. So vacuum decay is based on this idea that maybe the universe isn't fully stable, by which I mean maybe the laws of physics that we have in our universe are something that could change. So we know that in the very early universe, the laws of physics were different. When the universe was very hot and dense, in those first moments, the laws of physics acted differently with different numbers of particles in the universe, with different kinds of forces in the universe. And then something changed that set the laws of physics as they are now, as we have, electrons and protons and, all of the kinds of particles we deal with now, the way that electromagnetism works and the nuclear forces work, all of that was set up in the very early universe in the first kind of tiny fraction of a second. And the idea behind vacuum decay is maybe that a change like that could happen again and rewrite the laws of physics in our universe. And the way that would happen is that there would be some kind of quantum transition, so an event somewhere in the universe, a totally random event that we wouldn't be able to predict, would happen at some point in space, and it would create a bubble of a different kind of space where the laws of physics are different inside that bubble. And that bubble would then expand through the universe at about the speed of light and just destroy everything. So what would happen is this bubble, and the space inside the bubble would have different laws of physics, and there'd be kind of laws of physics where our atoms wouldn't be able to hold together anymore, and it would just be total destruction. And you wouldn't see it coming because it would happen at about the speed of light, so you'd have no way of knowing that it's heading toward you.
That's terrifying.
But you also wouldn't feel it because it would happen too fast. And this is the kind of thing that does scare a lot of people when they first read about it, because it sounds like this totally unpredictable, terrifying thing. But I should say that, based on our current understanding of how this process would work, first of all, we don't even know for sure if it could happen, but also we can say that if it is going to happen, it's almost certainly going to be so far in the future, trillions and trillions and trillions of years in the future, based on how long we think it would take before one of these bubbles would appear. So we think it would be a very, very, very long time from now.
Dr. Katie Mack joins us beyond the mic to break down the 5 cosmic disaster scenarios she discusses in her book, The End of Everything Astrophysically Speaking. We're at the final one. What is bounce?
Yeah, so this is one where the universe might go through some kind of cycle where it would have an end of the universe, like a big crunch, and then a new beginning, so a new big bang. And there are a couple of different ways it could happen. One with a kind of big crunch scenario, one with a sort of heat death scenario where you could have a new big bang coming out of that. So there are a few possibilities for this, and they're interesting because in some cases, some kind of little bit of information can travel from the previous universe to the next one. And some people find that sort of hopeful that maybe something will survive after the end of our universe. In
social media, you're mentioned with the same reverence as Dr. Neil deGrasse Tyson, Hawking, and Sagan. How rewarding is it to take complex physics and cosmology and boil it down so a kid or even a DJ could understand it? I mean, I find it really fun to talk about physics and astronomy and to share it with as many people as possible. And that means putting it into language that other, people who haven't spent their whole life studying physics would understand. I think that's a very important thing to do. And for me, it's just, I get excited talking about these subjects. I'm sure you can tell from my voice. I find this sort of thing a lot of fun. And so I don't want to just write papers for my colleagues who already know all this stuff. I want to write things for people who haven't spent their whole time in physics departments. And in order to do that, I need to find ways to translate it and, make it accessible. And that's a fun challenge, as somebody who enjoys writing and enjoys that kind of creative thinking. I think that is a fun thing, and that is a very rewarding thing to be able to let somebody understand something for the first time. That's a really wonderful experience. How do you balance the time of teaching, research, book activity, science outreach, and then just trying to find time for yourself?
That is something I'm still trying to figure out. It's definitely a challenge, but I'm very much helped by the fact that my university is so supportive in my outreach efforts. So they help me by letting me balance, do a little bit less teaching in order to do a little bit more outreach and to, change my expectations around various aspects of my job. So it's definitely, I'm definitely helped by that, but it's, every academic has trouble balancing all of their responsibilities. I'm certainly not alone in that.
Why should young girls get excited about STEM?
I think that everybody, all young people are excited about science. I think that children are naturally very curious and want to understand the world around them. And I think that, if we as a society are open to that curiosity, and if we as a society can deal with some of our hangups around various kinds of biases that we, far too often display, I think that will make everything better for everybody. So, I think it's not a matter of like, oh, we need to get people interested in STEM. I think that it's a matter of we need to make sure that we make academia and scientific research as welcoming as possible for everybody.
Talk about the powerful influence your family was in your development in becoming a cosmologist.
Yeah, no, my mom was super supportive of me growing up in terms of my interest in science. And she got me into science fiction as well, because she was always really into science fiction. And I used to steal her science fiction magazines, and she used to take me to the observatory for eclipses and stuff like that, and to public talks. So, my mom through both having an interest in science herself and supporting my own interest in science has been, a really great supporter.
What intrigues you most about the universe?
I think that I'm most intrigued by how much we are able to figure out and how much we will never ever know. I think that there those two things that we are constantly learning new things about the universe, but also we know that there are boundaries to our knowledge, both sort of in space and in terms of the information we're going to get. And that is fascinating to me, that there are parts of the universe we will never ever see because they're so far away and the universe is expanding too quickly. And that's deeply frustrating and also fascinating to me.
Time's running out, so it's time for the Rocky Nate. 8 random questions. Answer with the first thing that comes to your mind. There is no pressure.
Okay.
Last place you went on vacation?
France, somewhere in the mountains and skiing before all this stuff happened.
Do you remember what was the title of your last paper?
The title of my last paper was it was about a dark matter detector called Cygnus, and it was a feasibility study. I don't remember the full exact title, but it was a dark matter paper.
Okay, what's your go-to comfort food?
Cereal, breakfast cereal.
Class in college that bored you the most?
I feel I should not answer that question. I enjoyed college very much.
Who is the person at North Carolina State that mentors you?
Ooh, a lot of people do. I have some great colleagues in my department who are very supportive, and through the Leadership in Public Science cluster, which is the public science group I'm part of, who are very supportive. I don't want to name one person because there's so many people. It's a really supportive place.
Gonna put your feet to the fire. Favorite band?
I listen to a lot of different things. I'm gonna give a shout out to Hosier, who's actually also a friend of mine and does amazing music. Star
Trek or Star Wars?
Star Trek. Next Generation specifically.
Now, do you still have your pillow fort ready if you have to record more audiobook audio in the future?
I had to dismantle my pillow fort because I moved to a new apartment, so I would have to build it anew, unfortunately.
Her last vacation was skiing in France. She's a fan of Star Trek, The Next Generation, and her book, The End of Everything, Astrophysically Speaking, is available now. Dr. Katie Mack, thanks for taking the time to talk with me today.
Thanks so much for having me. This was great.
And that, my friend, is Beyond the Mic.